I'm Esther Norton. I'm a principal lecturer in the Department of Engineering and the Built Environment, Anglia-Ruskin University. I did my PhD in geotechnical engineering, so that kind of got me involved with soil and the ground and how it behaves. And when I finished, I went to live in Chile, and I lived in the north of Chile in the Atacama Desert, and I worked in a university. It was there because Chile is an extremely seismic country. I started looking into liquefaction. When I came back to England, well, this job came up at ARU. It was when I was starting. Someone had the idea about using a certain technique to mitigate the effects of liquefaction. And we started to think about a research project. This turned into the project Liquefact. It's taking the whole idea on a much larger scale and looking at the resilience of communities, not just single buildings. Because what liquefaction does is that it can cause critical lifelines to be disrupted. For example, in Christchurch, one of the worst effects of liquefaction was the wastewater pipes breaking because they were in a liquefiable soil. And this caused the most critical problem for communities in terms of kind of public health. What we want to find are 4 or 5 parameters that can be easily measured so that we can then, in our toolkit, allow engineers to assess whether the soil underneath their critical infrastructure could liquefy without having to carry out expensive, complicated tests. What the earthquake does is, when it applies the vibrations, its energy, to the soil, that makes the soil compact. The particles try to get closer together and they can't because the water's there. But the particles pushing in on the water increases the water pressure. This pushes the particles apart, so the particles are no longer in contact. They're essentially floating in the water. What we are hoping to do for the Eurocodes is produce some guidelines, particularly with respect to ways of retrofitting or improving the soil underneath existing buildings so that they have less potential for liquefaction. So I think that's what we want to have.